Okay, how's it going? All right, so for this video, we're going to talk about scalar multiplication, and we're going to start talking about how we can use matrices to show transformations. It's actually pretty cool, transformations of shapes in the coordinate plane. So let's start with scalar multiplication. Scalar multiplication is the distributive property. That's all it is. You're taking and dilating the entire matrix. You're either making it bigger or you're making it smaller. So for this example, we're taking the whole matrix and we're multiplying it by 2. Okay, so 2 times -3, 2 times 4, 2 times 7, 2 times 5, 2 times 8, and 2 times -9. All right, so let's try the next one. Again, multiplying the entire matrix by -1/2. So we're actually making it smaller, and then we're changing all the signs. And for this, you can actually leave your answers either as a decimal or an improper fraction. The choice is yours. So -1/2 times 10 is -5. -1/2 times -15 is now going to be a positive 7.5. -1/2 times positive 7, -3.5. -1/2 times 4, -1/2 times 8, and -1/2 times 0. We've just scaled the entire matrix. If that matrix represented a shape, then we would have just made the shape smaller. All right, last one. Okay, -3 times everything. Okay, and that's it. Scalar multiplication. So since we've done addition and subtraction, and we've now done scalar multiplication, we're going to talk about how we can use a matrix to represent a shape, and then we can use adding, subtracting, and scalar multiplying to actually transform that shape. It's actually pretty cool. All right, so let's take a look. Yeah, I'll need the desk, please. Yeah, just put it right there. I'll grab it. Thank you. Okay, so we're going to use a matrix to represent a shape, and it doesn't necessarily have to be a triangle. The matrix could be any size that we want, and we're going to transform it. Okay, so we have this triangle in the coordinate plane, and if we label our matrix to show that it represents this shape, okay, well, as stated down here, all your x values are in the first row, so that's x, and all your y values are in the second row. So we've labeled our rows, okay, and then we're going to label our columns. Well, -4, 3. 1, 2, 3, 4, 1, 2, 3. That would be point A, right? And -1, 2 would be point B, and -3, 1 would be point C. Okay, so we've got this 2 by 3 matrix that represents this triangle, triangle ABC, and the columns each represent a point, and the rows represent your x and your y variables. Now, this is very, very important as far as knowing this because of performing the transformations, okay? If I want to move this triangle 3 units to the right, so that's affecting the x's, and 4 units up, okay? I have to figure out what the matrix would look like that would perform that transformation, okay? So I'm going to slide down here so we can write it. So the actual original matrix, so that would be -4, 3, and -1, 2, and -3, 1. Okay, that's our original points, right? So if I want to transform this and make it 3 units to the right, so that affects the x, and 4 units up, that affects the y, I would need to add, and the matrix would have to be the exact same size, right? Otherwise we can't add. 3 units to the right, well, that's positive 3 on the x, and 4 units up, that's positive 4 on the y. So I would need to add these two matrices together, and here's the interesting part. The answer will actually give us the points where our new matrix is going to, our new shape is going to be. So negative 4 plus 3, negative 1 plus 3, negative 3 plus 3, 3 plus 4, 2 plus 4, 1 plus 4. Right? Okay. So we can actually graph those points. Remember, these are the x's, these are the y's. So this is going to be A prime, right? B prime, C prime, just like doing transformations back in 9th grade. Okay. We're going to graph that, and we can go ahead and graph it, and it will be in a different spot. So negative 1, 2, right there. Positive 2, 6. Did I do something wrong? Oh, negative 1, 7. I'm looking at the wrong thing. Silly me. Negative 1, 7. 2, 4, 6. I'm being silly. Negative 1, 7. 2, 6. And that's there. And 0, 5. 2, 3, 4, 5. There is our new triangle. And that's been moved 3 units to the right and 4 units up. So that's going to be A prime, B prime, and C prime. There we go. Okay. If I wanted to make this triangle 3 times as big, right, instead of moving it back and forth, up, down, back and forth, if I wanted to make it 3 times as big, what would I do? Well, we called scaling a dilation. So if I wanted to make it 3 times as big, I would multiply it by 3. I would multiply the whole matrix. And what I would get would be my original triangle stretched 3 times bigger. So negative 12, 9, negative 3, 6, negative 9, 3. And I'm not going to have any room on my graph to actually graph this because it would be off the page. But negative 12, 9 would be somewhere about right there. That's the first point. Negative 3, oh, maybe I do have enough room. Negative 3, 2, 3, 4, 5, 6. And then negative 9, 3. Negative 12, 9. Negative 3, 6, negative 9, 3. Okay, so I did it. All right, so that is my shape 3 times as big. And that's the result of where it would be. So there you go. There's our transformations. Okay, so we're going to do one more practice just to make sure you've got it. And we're going to do something that's a little bit bigger than 3 points. We're going to do 4. And we're going to do some moving downward and moving left because you're still adding to get those. You're just adding a negative. All right, so let's do another example just to make sure you've got it. All right, so let's see our new shape. Right. Let's see. Negative 4, 5. And B is 0, 6. And C is 3, 0. And D is negative 1, negative 4. So we have a 4-sided figure this time. Now the matrix still needs to be written with X and Y. And, the columns each representing a point. So it would be negative 4, 5, 0, 6, 3, 0, and negative 1, negative 4. So there's our original shape. 2, 3, 4, 1, 2, 3, 4, 5, 0, 6, 3, 0, 2, 3, 4. Now, I want to stress also with this is that you would not want your shape to be written in your matrix as like A, C, B, D. You want it to go in the order that it's supposed to go, like if you were playing connect the dots. You remember that when you were a kid? You would not want to connect A to C and then C to B and then B to D. That would not make a shape that we need. Okay, so make sure it's actually put in order, you know, alphabetical or however you're going to draw it. Now, it is perfectly acceptable to start at A and go to D. So you could do A, D, C, B when you're writing your matrix, and that would be fine. So you would have -4, 5, -1, -4, and that would be okay. But it does need to be in order, okay, in order that you could draw it. Okay, so let's transform this matrix. How about we do 2 units to the right and 3 units down. Okay, what would we have to add to go 2 units to the right for the x and 3 units down for the y? Okay, remember this is x and y, so we have to make sure we have it in the right place. So 2 units to the right is +2, right? My x's are going to get bigger. And 3 units down should be -3 because my y's are going to get smaller. So my new matrix as far as where it would be and where it would be transformed from are 2. Let's see, so -4 plus 2 is -2, 2, 5, and 1. And then subtracting 3 on all of those would be 2, 3, -3, -7. Right? So that would be where my new matrix points would have to be. So -2, 2, 2, 3, 5, -3 is right there, and 1, 2, 3, 4, 5. It's going to be right in the middle of where my work is. But that is the new matrix as far as the transformation. Okay? Now, how about I do more than one transformation, which we can. We can do that. We can do from the original, right, from the original matrix, -4, 5, 0, 6, 3, 0, -1, -4. How about we do 3 units left and scaled by half? We can do that. We just have to do this in order, okay? We have to do it in the order that we're told. So, because order does matter in this case. So, 3 units to the left means that I need to change the x variables, right? Not the y's, though, because I don't have anything where I'm going up or down. So, if I'm going to go 3 units left, I just need to change the x, and I can add zeros to my y because it doesn't change anything. And then I'm going to take that answer and multiply it by a half. So -7, -3, 0, -4. And then the y's stay the same. Right? And then I'm going to multiply the whole thing by a half. Okay, and that'll get me my new shape. So -3.5, -2.5, +2.5, sorry. -1.53, 0, 0 doesn't change. -2, -2. All right? Okay, so this is going to be my new matrix as far as my shape. So we're going to graph that one, and I think this time I'll graph it in, I'll just graph it in black. -3.5, +2.5, so 1, 2, 3.5, 1, 2.5, there's a point right there. Okay, -1.5, 3, 2, 3. Okay, 0, 0, and -2, -2. So my new shape from my original, remember the original is the purple, has been moved 3 units to the left. See, now C is over here now. And it's been shrunk by a half. So it's half the size that it normally would be. And we can do multiple transformations, and it works perfectly fine. Okay, so we're done as far as transformations. That's it for today, is scalar multiplication and transformations. So, for this lesson anyway. So now, again, we're still in 8.3. In fact, we're going to be in 8.3 for a while. And what pages are we going to be looking at now? Let's see. I think the same pages, though. Yeah, so 838 to 841. All right, for this lesson, I want you to do (11C) and (13C). Okay, and then as a challenge, I want you to do number 37. And then for your transformation practice, I want you to do 53, 54, and 55. Okay, so that's it for scalar multiplying. And for transformations, the next thing we're going to talk about is going to be multiplying, and that's a little bit more difficult. Okay, so talk to you later.